Hello and welcome to Machine Learning in the Era of Intelligent Systems, Opportunities, Challenges, and Emerging Frontiers. So, machine learning landscape, what people think about machine learning? Well, people think that machine learning is basically a robot or a dependable butler or a deadly terminator, but it has been around for decades in specialized applications like optical character recognition or OCR. The first main application that hit the market and affected many people was spam filter. It was followed by many ML applications ranging from recommendation system to voice search. Questions answered in this presentation. What is ML? Why you may want to use it? This is where we will have a lot of fundamental concepts that every data scientist should know about by heart. Machine learning is the science and art of programming computers so they can learn from data. A slightly more general definition would be machine learning is the field of study that gives computers the ability to learn without being explicitly programmed. And then a more engineering-oriented one, a computer program is said to learn from experience E with respect to some task T and some performance measure P if its performance on T as measured by P improves with experience E. This is from Tom Mitchell. Example from spam filter. Given examples of emails, a spam filter can flag emails to spam or ham. We can also say spam, non-spam. The examples that the system uses to learn are called a training set. Each training example is called a training instance or a training sample. So for task T, excuse me. The task T flagged spam for new emails. Experience E, the details for it is training data. The performance measure P needs to be defined example ratio of correctly classified emails. So if you download Wikipedia, you have lots of data, but your system is not suddenly better at any task. Thus, it is not an ML. So why use machine learning? Traditional approach to spam filtering. First, you would look at what a spam mail typically looks like and might notice words common in subject body and sender details like for you, credit card, free, and amazing. You would write detection algorithms for each pattern that you noticed. You would test the program and repeat steps 1 and 2 until the algorithm is good enough. So this is the traditional approach. We study the problem, we write rules, we evaluate, we analyze errors, and we launch. This is the traditional approach to solving problems, or spam filter in this case. The drawbacks for this is that long list of complex rules are hard to maintain. Spammer notices all the mails coming containing for you is blocked, so he or she can write something like for you instead of the number 4. Thus, new rule is needed every time. Machine learning approach. Study the problem and send parts of mail based on study to machine learning algorithm. Test the program and repeat step 1 until the program is good enough. So study the problem, train ML algorithm. We have data to train the ML algorithm. We analyze for errors, we evaluate the solution, and we launch. Again, studying the problem, training the ML algorithm on the training data or the training set, analyze, we evaluate the solution, we analyze for errors, we go back to study the problem again until we get to the launch state. The benefits of using a machine learning approach is that shorter program that learns the desired words on its own. ML algorithm notices on its own that emails marked by user as spam have for you frequently and thus starts flagging those mails. Automatically adapting to change. So with the data, we are going to train the ML algorithm. We have updated data. If we have new data, we'll use them to train the ML algorithm. We can evaluate the solution, and this whole process could be automated. Another area is where machine learning shines. Another area where ML shines is for problems that either are too complex for traditional approaches or have no known algorithm. Example would be speech recognition. So an ML can also help humans learn. ML algorithms can be inspected to see what they have learned, although for some algorithms this can be tricky. A spam filter can be inspected to see what words and what combinations of words it considers to be a spam. Applying ML techniques to dig into large amounts of data can help discover patterns that were not immediately apparent. This is called data mining. Machine learning can help humans learn. So we study the problem, we iterate if needed, we train the ML algorithm on lots of data, we come up with a solution, we inspect the solution, evaluate the solution, understand the problem better, and the loop goes on. To summarize, ML algorithms are great for problems for which existing solutions require a lot of hand-right tuning. Complex problems for which there is no good solution at all using traditional approach. Fluctuating environments. A ML system can adapt to new data, getting insights about complex problems and large amounts of data. 3 bases to classify machine learning algorithms. The first basis is whether they are trained using supervision or not. So the classification problem here, we have supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning. Whether they can learn incrementally on the fly, this would be online training and batch training. Whether they can work by simply comparing new data points to known data points, or instead detect patterns in the data. This would be innocence-based learning and model-based learning. These ideas are not exclusive. You can combine them in any way you like. Example would be a spam filter may learn to on the fly using a deep neural network trained using examples of spam or ham. This makes it an online model-based supervised learning system. Let's talk about supervised and unsupervised learning. So classification of ML algorithms based on amount and type of supervision they go. Supervised learning. In supervised learning, the trained data you feed to the algorithm includes the desired solution called labels. A labeled training set for supervised learning, we have training set, and we have then a new instance. So one example would be a new instance of the training data set. 2 typical tasks of supervised learning are classification and regression. For classification, example, classify emails to spam or ham. Model is trained using data containing mails with their classes. For regression, it predicts a target numeric value, such as price of a car given a set of features, such as the mileage, the age, the brand, etc. This is called a predictor. Model is trained using data containing both predictors and labels. This is how regression works. We have the value, we have a new instance, and we have a set of features, as you mentioned, like the mileage, the age of the car, the brand, etc. In ML, an attribute is a data, example mileage, while a feature has several meanings depending on the context, but generally means an attribute plus its value. Mileage equals 15,000. Many people use the words attribute and features interchangeably, though. Note that some regression algorithms can be used for classification as well, and vice versa. So you can use some regression algorithms for classification and vice versa. Some of the important supervised learning algorithms include k-nearest neighbors, linear regression, logistic regression, support vector machines, decision trees, and random forests, neural networks. Some NN architectures can be unsupervised or semi-supervised, as discussed in part 2. We have the unsupervised learning, where the training data is unlabeled. The system tries to learn without a teacher. An unlabeled training set for unsupervised learning. So we have an unlabeled training set for unsupervised learning. For unsupervised learning algorithms, we have clustering such as k-means, hierarchical cluster analysis or HCA, expectation maximization, visualization and dimensionality reduction, principal component analysis or PCA, kernel PCA, locally linear embedding or LLE, t-distribution, stochastic neighbor embedding or TSNE, association rule learning, a priori or ECPLAT. An example would be here grouping together blog visitors based on the genre they like and the time of the day at which they visit the blog. This is known as clustering. Another example of here, TSNE visualization highlighting semantic clusters. A related task is called dimensionality reduction, in which the goal is simplifying the data without losing too much information. You want to simplify the data, so reduce the dimensionality without losing too much information. One way is to merge correlated features into one. This is known as feature extraction, making new features from old ones. It is often a good idea to try to reduce dimensions of your training data using a dimensionality reduction algorithm before you feed it to another ML algorithm. It will run much faster, the data will take up less disk and memory space, and in some cases it may also perform better. Another important task is anomaly detection. An example here would be fraud transaction detection. So we have the training instances, everything looks normal. We have a new instance that doesn't look normal, so that would be an anomaly. Semi-supervised learning. Some algorithms can deal with partially labeled training data, usually a lot of unlabeled data and a little of labeled data. This is called semi-supervised learning. Some photo hosting services, such as Google Photos, are good examples of this. It automatically recognizes that the same person A shows up in photos 1, 5, and 11, while another person B shows up in photos 2, 5, and 7, clustering. Now, the system needs you to tell it who these people are, just one label per person, and it is able to name everyone in every photo. So semi-supervised learning. Most semi-supervised learning algorithms are combinations of unsupervised and supervised algorithms. Reinforcement learning, the reinforcement learning system called an agent in this context can observe the environment, select and perform actions and get rewards. It must then learn a strategy called a policy to maximize the reward. So this is how reinforcement learning works. So it will observe, select action using policy, action, get reward, or penalty, update the policy, learning step, iterate until an optimal policy is found. Batch and online learning. Classification of ML algorithms based on whether or not the system can learn incrementally. Batch learning. The batch learning of the system is incapable of learning incrementally. First, the system is trained and then it is launched into production and runs without learning anymore. It just applies what it has learned. This is called offline learning. If you want a batch learning system with new data, you will have to train a model offline and then replace old model with this new model. Training a whole lot of data requires a lot of computing resources. If the amount of data is huge and you train from scratch every day, it will cost you a lot of money. If the system with limited resources needs to do learning, it is very difficult to carry around large amounts of data. Now we have online learning. In online learning, you train the system incrementally by feeding data instances, either individually or by small groups called mini batches. Each learning step is fast and cheap, so the system can learn about new data on the fly as it arrives. So we have data, we train the ML algorithm, we evaluate the solution, we launch, we run and learn, we have new data, and we repeat the cycle. Online learning is good for systems that receive continuous flow of data and requires to adapt to change abruptly. It is also a good option if you have limited computing resources. Online learning algorithms can also be used to train systems on huge data sets that cannot fit in on machines' memory. This is called out-of-core learning. This whole process is usually done offline, not on live systems. So online learning can be a confusing name. Think of it as incremental learning. Learning rate. This is an important part of online learning systems. It means how fast the systems should adapt to data. If it is too high, the system will adapt soon, but will tend to forget soon too. If it's too slow, the system won't adapt to the data. A big challenge with online learning is that if bad data is fed to the system's performance will gradually decline. If you are talking about a live system, your clients will notice. Instance-based versus model-based learning. One more way to categorize machine learning systems is by how they generalize, meaning perform on new instances which weren't present in training data. There are two main approaches to generalization: instance-based learning and model-based learning. The most trivial way of learning is to learn by heart. A spam filter made this way will not flag emails which are identical or might be very similar to the ones flagged by user. Often to find the similarity between two images, a metric is used known as measure of similarity. So the system learns the examples by heart and then generalizes to new cases using a similarity measure. Model-based learning, another way to generalize from a set of examples, is to build a model of these examples, then use that model to make predictions. This is called model learning. So we have features, we have the model, and we have the feature set here. Main challenges of machine learning. Two things that can go wrong are bad algorithm and bad data. Insufficient quantity of training data. It takes a lot of data for most machine learning algorithms to work properly. Even for very simple problems, you typically need thousands of examples. And for complex problems, such as image or speech recognition, you may need millions of examples. The unreasonable effectiveness of data. In a famous paper published in 2001, Microsoft researchers Michelle Banco and Eric Brill showed that very different machine learning algorithms, including fairly simple ones, performed almost identically well on a complex problem of natural language disambiguation once they were given enough data. And this is the end of the presentation. Thank you.